start recording. So yeah, we're going to do 47, 48, and 55. Take notes on those, submit them today before the end of class for credit. And then your homework is a worksheet on what we're learning today and some things we learned in the past, like these two are a review. Today, we're learning this part, solving by the equal values method. Okay, so that's your homework. That is due Tuesday, since we'll meet again on Tuesday. We won't meet on Monday for the holiday. So let's go over to, if you have your CPM books open, to 621 here. We are looking at starting with number 44. We're not going to do 44. We're just going to read it. Solving systems of equations using the equal values method. Okay, let me get my Jamboard up here so I can write on it. So here's a set of two or more equations with the same variables is called a system of equations. When you set the two expressions that are equal to the same variable equal to each other, like you did in the previous lesson, you are using the equal values method of solving a system of equations. Use the equal values method to solve the following problem. And then it goes on to talk about a hot tub problem. Here it goes. It is time to cool off on a hot summer day. Team Sunshine is filling an inflatable kiddie pool from a garden hose. The pool has 30 gallons in it, and Team Sunshine is adding 8 gallons per minute with hose. So that's a rate or a slope, and this is the capacity of the pool. Next door, Team Breeze's pool is already filled with 180 gallons of water. They are emptying the pool at 5 gallons per minute. So if they're emptying the pool, your rate is going to be what? What do we know about the rate?
It's negative.
I don't know if somebody said negative, but yeah, it's going to be negative because you're emptying the pool. Okay. And so we would have to come up with some equations here. Write two equations to represent the situation. Use these equations to find how long it will take both pools to have the same amount of water. Excuse me. Okay, so we could write equations for this, and we're going to do word problems later on. Today, we're just going to learn the math behind solving a system of two equations, and we'll come back to problems like 44, 45, 46. We're actually going to skip those today, but we will come back to them. They're important. We're going to move on to 47, where it says when you write equations to solve word problems, you sometimes end up with two equations like Renard's that are similar to each other. And we can rewrite one of the, so one of the equations is y equals -1/2 x plus 4. The other equation is x minus 2y equals 4. So it's not in y equals form, but we can change it to y equals form using the methods that we've been using the last couple sections. So let's go ahead and write this down for 47. I'm gonna go back to my Jamboard here and write 47. So there was a math notes part in your book right before the homework review preview. You can read that. You can put it in your notebook if you want to. I'm not going to do it with you here, but you can certainly do it. And we're going to do 47. So we're going to write down these two problems. Get my pen here. So we have x minus 2y is equal to 4. And then the other equation, so a system, they're usually right one above the other like this, y equals -1/2 x plus 4. So this is called a system of equations, right? System, because it has two, so it makes a system of equation. We want to solve the system, right? And these are usually like some word problems, like, I don't know, like the pool, right? The pool is emptying at 2 gallons per minute here. And well, actually, it would be -2x would be here. Let's say this pool is emptying at 1/2 gallon a minute, and there's 4 gallons of water in the pool. So y would represent how much water there's currently in the pool as it drains, right? So you have pool, boom, 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 and there's water in it, water, and it's draining, right? So it's getting lower and lower. So we can find how much water is in the pool at a certain amount of time. All right, so to solve this, we're going to use equal values. If you didn't write the title of this, which was 6.2.1 right here, equal values method, let's go ahead and write that at the top of our paper. Equal values method. Okay, because that's what we're doing today, 621 equal values method. And here is our system. If you didn't write 647 down, we want to solve this using equal values. Well, equal values means we're going to get both of the equation to look like this, be a y equals, right? This one does not have a y equals, so we need to do some work for this one. So I'm going to recopy this one over here, x minus 2y equals 4, and I want to solve it for y, right? So what is our first step we need to do to solve this for y? We need to minus x from both sides, right? Bring the x to the other side. So we get negative 2y is equal to negative x plus 4. All right, one more step to solve for y, right? We need to get rid of this negative 2. How do we get rid of that negative 2? Feel free to unmute yourself or write in the chat how to get rid of that negative 2. Good, I got one answer in the chat, yay. We're going to actually divide by negative 2, okay, because it's negative 2 times y, right? So the opposite of times y is divide by negative 2. So what does that give us here, guys, for our y equals equation? So we divide by negative 2, we get y equals a negative divided by negative. Remember, there's an imaginary 1, negative 1 in front of here. A negative divided by a negative gives me positive 1/2 x. And then when I take 4 and divide it by negative 2, I get negative minus 2. Okay, so this is how you simplify the right-hand side there. Negative 1x divided by negative 2 is positive 1/2 x. Positive 4 divided by negative 2 is negative 2. So we have these two equations in y equals form now, right? Like, hey, we know y equals this and y also equals this. And these are two different lines, right? So one pool is filling up because it's positive. The other pool is emptying because it's negative. And at some point, they're going to have the same amount of water. And that's what we want to find. At what point do they have the same amount of water? Well, since both of these are equal to y, it means we can set the right-hand side, this right-hand side, equal to this right-hand side, because that's what y equals, and this is what y equals. So these two should equal to each other. That is called the equal values method. Okay, so I'm going to take the negative 1/2 x plus 4 and set it equal to the other part of the right-hand side of the equation, 1/2 x minus 2. And that is using the equal values method. Now we need to solve this for x by, I would probably add 1/2 x here and add 1/2 x here, right? Hopefully that's what you would do too. And I would get 4 equals 1/2 x plus 1/2 x is a whole x minus 2. Okay. And I'm going to add 2 to both sides, add 2, add 2. Move this bar that always plagues me out of the way. You can't see the bar, but I can. It's pretty annoying. Okay, so 6 equals x. So x equals 6. So one of the solutions is 6. But how many variables does our system have? Does it have 1 or 2 variables, guys? Somebody unmute themselves, please. Let me know you're there. Does this system have 1 or 2 variables? Okay, in the chat, we say it has 2. So we've only solved for 1 variable, x equals 6. So that means we have to go back and solve the other variable. What is our other variable? Y, right? Good. Somebody unmuted themselves. Y. So we have to go back and solve for y. Well, we have 2 equations with y in it. We actually have this equation and this equation. I can use either equation that I want to. This one, I've kind of manipulated for this one, so I might not want to use that one in case I made a mistake. But if I did make a mistake, then that would give this mistake. So you can use any one you want. You know, I am going to use this one. I was going to say, go ahead and use this one because this one's not manipulated, but it's got that negative in front. I don't want to deal with that negative, so I'm going to use this one. Y equals 1/2 times 6 minus 2. Well, 1/2 times 6 that is just half of 6, which is just 3. So 3 minus 2 is our value of y, 1. Y equals 1. So it's great that you have answers like this, but you should not leave them like this. You need to write them as a coordinate, right? You need to write them as a coordinate, an XY coordinate in this form, or what we call an ordered pair. It's also called an ordered pair. You need to write it as an ordered pair or as a coordinate. So X always goes first, alphabetical order. X goes first. So 6 was first, and then Y goes second, 1. So the coordinate where they intersect, that tells me the coordinate where they intersect right here is 6, 1. So that's why we write it as the answer as a coordinate, right? If this was a word problem and X was the time, then I would say at 6 minutes or after 6 minutes, the pool has 1 gallon of water in it. Okay, if it was a word problem, that's what I would do. That's what the 6 would represent. The 6 would be, or how much time. So after 6 minutes, the pool has 1 gallon of water in it, if this was that word problem that we were talking about earlier. All right, guys, so there's one example of the equal values method. I'm going to do 2 more with you. Actually, there's one you could do on your own, but let's go to the next one. I'll think about that here if I do it with you or let you do it on your own. 48. So 48 gives us another system of equations, and we want to solve this. Are they solved for y yet? Do they say y equals yet? No, right? So let's copy these equations down. 648. We have x plus 2y equals 14. Usually we write the system like stacked like that. I'm going to write them next to each other. Negative x plus 3y equals 26. Okay, I'm going to write them instead of up and down next to each other. And the reason why I'm doing this is I know we have to change this to y equals, right? We have to get both of them to be y equals. So we have 2 steps to make this be y equals. What's the first step, guys? What do we have to do first? We have to move the x to the other side first, right? So we have 2y equals, put the x first, negative x plus 14. Okay, the x goes first and then the number goes after, to y equals mx plus b form. Divide by 2 on both sides, and look how we divide by 2. Okay, we take the first number divided by 2. If there is no number there, that's an imaginary 1, right? So negative 1/2 x, because a negative divided by a positive is negative. If there were 2 negatives, I make it positive. Plus, and then the 14 divided by 2, positive 14 divided by 2 is positive 7. So we have a y-intercept of 7, a slope of negative 1/2. All right, we need to do the same thing with this equation. Solve it for y, get it to be y equals, just like this one, right? So let us again bring the x over to the other side. Let's add x. And we get 3y is equal to, put the x first, x plus 26. Now we need to get rid of the 3. So to get rid of the 3, I'm going to divide by 3, divide by 3. There's an imaginary, there's nothing here, but really when there's nothing with the x, it means it's 1x. So we have 1/3 x. You can kind of make this heart thing here. Perfect for Valentine's. Y equals 1/3 x. So here's the heart plus this part, 26 divided by 3. 26, is that what I had? I feel like, no, that is not right. I messed up somewhere. Where did I mess up, guys? Negative x, 3y equals 26 minus x divided by 3. Oh, I know I guess that's right, plus 26/3. Oh, it's because I did it a different way earlier this morning. I was like, I didn't do this morning. It's because I did it a different way. Okay. So this is okay. This is good, I think. I didn't find a mistake. So we have two y equals equations, right? We have this and this. So now we can set them equal to each other. We can set this part equal to this part, right? They're both y equals, so we can basically drop the y's and set these two parts equal to each other. So let's go ahead and do that. Let's do -1/2 x plus 7 is equal to 1/3 x plus 26. We hate fractions, right? You're probably looking at this like, this is messy and ugly and yucky, but it's not that bad actually, because we can fraction bust. Yay, let's fraction bust. If I want to fraction bust and get rid of this fraction, and that fraction, I can multiply by something. What should I multiply by to get rid of the 2, the 3, and the 3? The half and the thirds. What could I multiply? What is the lowest common multiple of 2 and 3? Good. One person's answering in the chat. 6. Good job. Lowest common multiple is 6. So let's multiply the whole thing by 6. Okay. When I multiply a half of 6 times negative would be -3x, right? Half of 6 is negative and there's an x there. When I multiply 6 times 7, that's pretty too. That's easy. It's 42. When I multiply 6 times 1/3 x, the 3 goes into 6 2 times. So I get 2 times x, which is 2x, plus, and then when I multiply the 6 by this 26/3, that's easy too, because 3 goes into 6 2 times. So then I multiply 6 times 26. What is 26 plus 26, or 26 times 2, 12, 1, 52. So plus 52, fraction busted. All fractions are gone now that we multiplied it by the lowest common multiple. So hopefully you understand how that fraction buster worked. That's an important step right there, what I just did from there to there. Not, you can watch the video that I'm going to post later and rewatch that. All right, so I'm going to bring this 3x over here because it's a negative and I want to get rid of that negative. So let's add 3x over here, add 3x over here. And I'm going to get 42 equals 5x plus 52. No fractions. I'm running out of room, so I'm going to rewrite that over here. 42 equals 5x plus 52. 2 more steps to solve this linear part that you should be used to. What should we do next? Subtract 52 from both sides, right? So I get 5x is equal to -10. Okay, almost done. Now we need to divide by 5. Divide by 5. So x equals -2. Yay, we got a whole number. Can we get a fraction and not a whole number? Yeah, sure. You could get a fraction for some of these, but usually they come out whole numbers because your book wants to be nice and make it nice and easy, right? So we solved for x. We're not done because now we have to solve for y, right? To solve for y, we can plug it into either the original equation number 1, the original equation number 2, or I could plug it into this equation that's already solved for y, that one, or this one. I probably wouldn't pick this one because it's got that ugly fraction in it. So I'll pick that one right there, okay? I'm gonna have to erase some of this. So I'm going to like erase this part so I have room to work. Sorry, I don't think any of you need that because I wrote that a while ago. Hopefully you didn't need that. Sorry if you did. And so I'm going to plug in -2 into this equation to find y here. Y equals -1/2 times -2 plus 7. So a half of 2 is 1, and a negative times a negative is a positive. So that's +1 plus 7 is equal to y. So y equals 8. Okay, so now we just need to write our answer as an ordered pair. So our answer, x is -2 and y is +8. And if this were some word problem, which it should be, then I don't know, the time would be -2 hours and your gallons or feet per second or whatever would be 8. Okay. So, whew, all right, that's 48. So 55, okay, I gotta clear this away. So this is gonna go away. And the last problem that we're gonna look at is 55. Is the same. So this is actually on the next section. This is on 622, but it just says review what you learned from 621, which is what we just learned, and solve the system. Okay. Okay, I think I'm gonna let you do that on your own. I'm just gonna cut this short and we'll be done, guys. So it's the first one is already solved for y. The second one you have to solve for y, so you got to bring the x over here and then get rid of that 5. And do you get a fraction when you do that? Yeah, you're gonna get a fraction. You're gonna get like what, -13/5 on the right hand side of the equation, and you're gonna get some kind of x over here, -13/5. But that's okay, because later on you can multiply by 5, right, to get rid of that, to get to fraction bust for this problem. So it's not bad. I'm gonna tell you what the answer is so you can check your work when you do it, okay? And the answer is gonna be -11/4 right there. So I'll write that down. When you do this problem, you should get -11/4. So x is going to be -11, y is going to be 4. Okay, and I'm going to let you do this on your own because I just did 2. So try it on your own. If you get it wrong, then you can rewatch this video after I post it and watch how I did the other 2 and redo it. But that's going to be your answers that you get. Okay, guys, any questions on any of this? Okay, so you're gonna submit these notes after you do 55. Should take you like 5 minutes to do this. You're gonna submit this into the Google Classroom. Move this bar. You're gonna submit it into, the bar is still in my way. You're gonna submit it into not the homework, but A13, and we skipped 12. 12 was supposed to be the Wednesday assignment. I was supposed to give you a Delta assignment, but I just had you do the worksheet. So there is no assignment 12. So this is where you want to submit your homework, your classwork, the notes that we just took after you finish number 55. So number 55 should take you 5-10 minutes to do, and then you're going to submit it here. And then your homework is the worksheet, which is due Tuesday next class period, because Monday we have off, and you can work on that when you're done. And we're done really early, like it's only half an hour, so it gives you plenty of time. You could do the homework today and be homework free if you like for the weekend.